Hitler's 200-ton armored tank, the most insane war machine in history. Imagine a steel monster the size of a two-story building, weighing as much as 10 medium tanks combined. Its armor was so thick that no anti-tank gun of the era could penetrate it. This colossus was meant to turn the tide of World War II and open the path to Moscow for German forces. Hitler personally approved its creation and demanded mass production begin as soon as possible. But this machine had one fatal flaw: it was too heavy even for itself. In the spring of 1942, the war was going nothing like Germany had planned. The blitzkrieg that had brought stunning victories in Poland and France had bogged down in the vast expanses of the Soviet Union. German panzer divisions, once seemingly invincible, were getting stuck in Russian mud and breaking down in the frost. Soviet T-34s and KV tanks proved far more resilient opponents than German strategists had anticipated. Hitler was furious. He needed a wonder weapon that could reclaim the initiative on the Eastern Front. The Führer summoned representatives of Germany's largest engineering conglomerates and set before them a task that seemed mad to many. He demanded a tank that would be absolutely invulnerable to any enemy weapon. The armor had to be thick enough that Soviet shells would simply bounce off it like peas off a wall. Its armament had to be capable of destroying enemy tanks at ranges where they couldn't even return fire. Size and weight were irrelevant. What mattered was a machine of absolute supremacy. The contract went to Porsche, a company celebrated for its engineering. Ferdinand Porsche, the firm's founder, was Hitler's personal favorite and enjoyed his complete trust. The original specification called for a 100-ton tank, which was already considered fantastic. The heaviest German tanks of the day weighed no more than 57 tons, but Porsche's engineers decided to go further and exceed the Führer's every expectation. When the design blueprints landed on Hitler's desk, even he was momentarily taken aback. Before him was documentation for a combat vehicle weighing 200 tons. The frontal armor was 25 centimeters thick, more than many warships of the era. The sides were protected by 18 centimeters plates of hardened steel. Even the roof had 6 centimeters of armor, making it impervious to small-caliber aerial bombs. The turret was planned to carry a 128mm gun capable of penetrating the armor of any existing tank at a distance of over 2 kilometers. Hitler was thrilled. He imagined these steel monsters carving through Soviet defenses, sweeping everything aside. No anti-tank guns could stop them. No mines could pierce their floor. They would move slowly but inexorably forward, turning enemy fortifications to rubble. The Führer immediately approved the project and demanded the first prototype be built in the shortest possible time. The project was given a code name meant to convey its power and unstoppability, but engineers, with dark humor, christened the behemoth something else entirely: Maus, meaning mouse. Feverish work on the prototype began. The engineer's greatest headache was the engine. Moving 200 tons of steel required a motor of monstrous power. They first tried adapting the Daimler-Benz MB 509 aircraft engine, a massive 12-cylinder unit used in bombers. But even this power plant couldn't cope. The tank either didn't move at all or crawled at walking pace. Engineers then installed the even more powerful Daimler-Benz MB 517 diesel. This monster produced 1,000 horsepower, but together with the generator it occupied 2/3 of the entire interior space. The crew of 5, commander, gunner, loader, driver, and radio operator, were left with just a few square meters. By May 1943, a full-scale wooden mock-up was ready for Hitler's inspection. The Führer arrived at the secret test ground and walked around the giant structure several times. The tank stood 3.5 meters tall, stretched over 10 meters long, and was nearly 4 meters wide. It was a true land leviathan. Hitler demanded several modifications and immediately signed an order for serial production of 150 vehicles. The war was to receive its wonder weapon. While Hitler was already dreaming of victorious Maus parades across Red Square, engineers were confronting a reality far less rosy. The first running prototype was ready by late 1943, and that was when the real ordeal began for everyone involved. When the 200-ton hulk first rumbled its diesel heart and slowly moved from its spot, the assembled officers and engineers held their breath. The tank rolled forward across the paved test ground surface, and within a few meters, deep cracks began appearing beneath its tracks. The concrete, designed for the movement of ordinary heavy vehicles, simply crumbled under the Maus's incredible mass. Each track left a furrow several centimeters deep. The road surface deformed and broke apart, as if a herd of elephants had passed, not a tank. It became obvious that no existing road in Germany could withstand this colossus moving across it, and the plan called for 150 such machines to somehow be transported to the front. Trials continued on dirt roads, and things were even worse there. On soft ground, the Maus's tracks sank half a meter deep. The tank literally plowed the earth like a giant plow, leaving deep trenches behind it. On the slightest incline, the engine began to overheat, and speed dropped to a snail's pace. The driver reported that operating the machine was incredibly difficult. The slightest turn required enormous effort, and the braking distance stretched for dozens of meters. Any attempt to stop sharply caused the tank to bury its nose in the ground under its own weight. The maximum speed coaxed from the prototype was just 20 kilometers per hour, and only on a perfectly flat, hard surface. By comparison, the Soviet T-34 reached 55 kilometers per hour and the German Tiger 45 kilometers per hour. Any enemy tank could simply drive away from the Maus while firing on it from a safe distance. Even infantry on the march moved faster than this steel giant. The idea of a rapid breakthrough through enemy defenses collapsed to dust. The real nightmare began when the Maus was driven over a bridge. German engineers had reinforced the crossing in advance, calculating loads with a large safety margin. The tank began slowly crawling onto the bridge, and roughly at the midpoint the structure began emitting an ominous grinding. The support beams bent, cracks ran through the concrete, and the crew commander ordered an immediate retreat. The bridge held, but after the Maus's passage it was declared unfit for further use and sent for major repair. It became clear that no existing bridge in Europe could bear this monster. Engineers frantically searched for a solution to the crossing problem. Some proposed building specially reinforced bridges ahead of every advance, but this would mean the Maus moving at the speed of construction work. Others suggested transporting it disassembled and building it on site, but the very idea of dismantling and reassembling a 200-ton machine somewhere in field conditions seemed absurd. Then Porsche's engineers proposed an idea that sounded like science fiction. The Maus would ford rivers along the bottom, moving underwater like a submarine. To carry out this insane plan, the hull was completely sealed. All hatches were fitted with rubber gaskets, and an 8-meter telescoping snorkel tube was mounted on the turret to supply air for the engine and crew. Exhaust gases were routed through special valves capable of operating under water pressure. But even here, a problem arose. Underwater, the Maus's engine could not generate enough electricity to drive the tracks. The solution was unusual. A second Maus would remain on the bank and transmit electricity through a special armored cable several dozen meters long to the first tank crawling along the riverbed. The first underwater crossing trial was conducted in a small river about 5 meters deep. The crew climbed inside the sealed tank with obvious unease. The prospect of getting stuck on the riverbed in a 200-ton steel coffin pleased no one. The Maus slowly slid into the water. The snorkel protruded above the surface like a periscope, while the second tank on the bank hummed its engine, generating electricity. To everyone's surprise, the system worked. The tank crawled about 100 meters and emerged on the opposite bank, coated in river silt and weeds. But the joy was short-lived. Engineers quickly calculated that crossing a serious water obstacle, such as the Dnieper or Vistula, would require a cable several hundred meters long. Laying such a cable under enemy fire was a suicidal operation. Moreover, while one Maus crossed, the other had to stand on the bank completely defenseless, serving as a living power station. And what if more than 2 tanks needed to cross? Build an entire chain of vehicles passing energy to one another. The absurdity of the situation became ever clearer. Then another catastrophic problem emerged: range. The giant diesel engine consumed fuel at a terrifying rate. Even fully fueled, the Maus could travel just 65 kilometers on a hard road. On rough terrain, this dropped to 40 kilometers. The tank could effectively move for just 3 hours before becoming an immobile fortress. By comparison, the T-34 covered 300 kilometers on a single fill, and the Tiger 140 kilometers. Supplying an armada of Maus tanks would have required an unprecedented logistics system with constant refueling every few hours. General Heinz Guderian, the father of the German Blitzkrieg and the greatest tank strategist in Germany, inspected the Maus at trials and called the project grandiose. But everyone understood that in his mouth the word sounded more like sarcasm. Guderian argued for producing large numbers of medium tanks, fast and maneuverable, capable of swift strikes. The Maus was the complete opposite of that philosophy, slow, voracious, ungainly, demanding an army of support staff and mountains of resources. By early 1944, it was clear that even if the Maus somehow made it to the battlefield, getting it there would be a separate epic challenge. German railroad officials threw up their hands when shown the blueprints and asked to calculate the possibility of transporting it. No existing flat car could bear such weight. The 200 tons spread over an area of several dozen square meters created pressure capable of deforming rails and destroying sleepers. A special flat car had to be designed with a reinforced frame and 24 axles instead of the standard 4. Even this could travel only on main lines with the sturdiest rails, and reinforced concrete sleepers. Ordinary wooden sleepers began cracking under the weight of the train after just a few kilometers. Speed was limited to 15 kilometers per hour. Any faster and derailment threatened. From factory to front, such a convoy would take weeks. Loading and unloading the Maus became a multi-hour operation requiring the most powerful cranes and special ramps, conditions that simply didn't exist at the front. Military logisticians calculated that supporting combat operations for even one battalion of 10 Maus tanks would require a dedicated railway spur, dozens of fuel tanker wagons, hundreds of supply trucks, and an entire army of technical personnel. Yet Hitler dreamed of 150 such machines. Meanwhile, the situation at the fronts was changing with catastrophic speed. The Battle of Stalingrad ended in February with the complete destruction of a German army, 300,000 soldiers taken prisoner or killed. It was the first truly large Soviet victory, and it broke the course of the entire war. The Red Army went on the offensive along the entire Eastern Front. The summer brought the massive tank battle at Kursk, where the Germans threw their newest Tigers and Panthers into battle, but Soviet tankers held and drove the enemy back. By autumn, Soviet forces had crossed the Dnieper and liberated Kiev. The front line was rolling inexorably westward. Germany had gone from aggressor to defender. Now the Germans needed not slow breakthrough tanks, but fast machines for counterattacks and containing the enemy's momentum. The Maus, with its 20 kilometers per hour, was utterly useless in such conditions. Work on a second prototype continued at the test ground. Engineers tried to eliminate at least some of the identified flaws. A more advanced cooling system, an improved transmission, reinforced suspension, but the fundamental problems remained unsolvable. There was no way to make 200 tons of steel move fast without an engine of incredible power that simply wouldn't fit inside the hull. The laws of physics proved stronger than Hitler's ambitions. In June came an event that definitively buried all hopes for mass production. The Allies landed in Normandy, opening a second front. Germany was now forced to fight on two fronts. Its resources, stretched to the limit, factories were running at maximum capacity, producing ordinary tanks, aircraft, and artillery. Oil was desperately short. Romania's oil fields were under constant Allied bombing. Every ton of steel, every liter of fuel was accounted for. Squandering colossal resources on experimental giants that couldn't even move properly was an unaffordable luxury. Albert Speer, Germany's Minister of Armaments, presented Hitler with a report. The cost of one Maus equaled that of 5 Panthers or Panzer IV's. The resources required to build 150 super-heavy tanks could instead produce more than 1,000 medium tanks capable of actually influencing the course of combat. Speer insisted on cancelling the program and redirecting all capacity to proven equipment. Hitler resisted. He still believed in a wonder weapon that would change the course of the war. By autumn 1944, the Red Army had reached the borders of East Prussia. Romania, Bulgaria, and Finland had left the war. Soviet tanks stood at the gates of Germany itself. In the west, Anglo-American forces had liberated France and Belgium and were preparing to invade German territory. The Third Reich was shrinking, losing one position after another. In this situation, any long-term projects were meaningless. Weapons were needed here and now, not in a year or two. In November, Hitler finally signed an order for the complete cessation of work on the Maus project. All resources were directed toward the production of conventional tanks and anti-tank artillery. The two built prototypes remained at the Kummersdorf test ground near Berlin. It was planned to use them in the defense of the capital, if a direct threat materialized. But even in the most desperate plans of the German command, these giants found no worthy role. The dream of an invincible steel colossus had shattered against the reality of war and the laws of common sense. The two giant prototypes stood at the test ground as monuments to unrealized ambitions. The first was fully equipped with a turret and gun. The second remained without a turret. It simply hadn't been installed before the project was cancelled. A small group of engineers and mechanics continued tests, though everyone understood this no longer served any practical purpose. The tanks were driven around the ground, their characteristics measured, various systems evaluated. Once they even fired the main gun, the 128mm cannon showed superb accuracy and power. But what good was a deadly weapon whose carrier could barely crawl? The winter of 1,940 forces were advancing rapidly through Poland toward the German border. The German army was falling back, abandoning one defensive line after another. In the west, Anglo-American forces were fighting in the Ardennes, repelling the last major German offensive. The Reich was contracting like shrinking leather, losing territory and resources. Berlin was preparing for siege in January. The Red Army launched the Vistula-Oder offensive. Soviet tank wedges burst through the German defenses and poured deep into Germany. In a few weeks they covered the distance from the Vistula to the Oder, almost 500 kilometers. The pace of the advance was so swift that the German command simply couldn't organize new defensive lines in time. T-34s and IS-2s moved day and strongpoints and driving forward. By month's end, Soviet advance units were just 70 kilometers from Berlin. The Kummersdorf test ground lay directly in the threatened zone. German command ordered all valuable equipment evacuated and anything that couldn't be moved destroyed. Engineers received orders to blow up both Maus tanks. The enemy must not be allowed to capture these unique machines. Soviet intelligence already knew of the existence of the super-heavy tanks and very much wanted to obtain them for study. The Germans understood what technological value these prototypes represented. Demolition teams planted explosives in both tanks. The first Maus, with its turret, was thoroughly destroyed. A powerful explosion tore open the hull. The turret flew off its ring and tilted sideways. The tracks were blown to pieces. Only heaps of mangled metal remained. With the second prototype there was a hitch. Not enough explosives were left. The charge was weaker than needed. The explosion damaged the running gear and engine but left the hull relatively intact. There was no time to reset the charge. Soviet reconnaissance groups were already appearing in the vicinity of the test ground. On April 21, 1945, Soviet sapper units entered the territory of the test ground. The Germans had retreated, abandoning all equipment and documentation. Among the rubble of destroyed buildings and bomb craters, Soviet soldiers found the remains of two giant tanks. The sapper battalion commander was stunned by the size of the machines. Even in their wrecked state, these steel monsters made a formidable impression. Soldiers clambered over the tanks from every angle, marveling at the thickness of the armor and the scale of the construction. Military intelligence officers immediately reported the find to Moscow. The order came back unambiguous: evacuate both tanks at any cost. Soviet command understood perfectly that the German engineers had not spent all those resources for nothing. Studying the design could yield valuable information on German technologies in tank building, metallurgy, and engine manufacture. Moreover, these were the only tanks of this class in the world, a truly unique prize. The transport became a genuine engineering epic. First, Soviet specialists assembled one reasonably intact tank from the wreckage of the two prototypes. The undamaged turret from the badly destroyed first Maus was lifted and placed on the hull of the second, which had suffered less. The tracks were replaced and the engine repaired as best as field conditions allowed. The result was a hybrid of two machines, but at least it represented a relatively complete specimen of German engineering. To carry the tank they had to find the most powerful flat car available, the very special German 24-axle platform that had been designed specifically for the Maus. Along war-ravaged railways the convoy crawled at walking pace. Bridges were circumvented, routes chosen for the sturdiest crossings. The journey from Germany to Kubinka, the testing ground for captured equipment near Moscow, took nearly 2 months. The train moved only by day, under guard, with constant stops to check the track and the flat car. That summer, the Maus arrived at the Kubinka test ground. Soviet engineers meticulously measured the tank, photographed every detail, disassembled every accessible component, and conducted several running trials, confirming that the German calculations were correct. The tank did indeed reach about 20 km/h and consumed fuel at an appalling rate. They tested the armor by firing captured German anti-tank guns at it. The shells bounced off without causing damage. It became clear why Hitler had believed so fervently in the project. But Soviet designers reached the same conclusions the Germans had. Super-heavy tanks were a dead end. Low speed, enormous fuel consumption, and problems with transport and maintenance made such machines unfit for real war. The USSR was developing its own heavy tanks at the time, but even the most massive IS-3 weighed only 45 tons, more than 4 times lighter than the Maus. Soviet tank design went the route of balanced machines with an optimal ratio of protection, firepower, and mobility. For several years, the giant tank stood at the test ground as a silent witness to the mad ambitions of a Germany that had lost the war. From time to time, it was shown to military delegations from friendly countries as an example of what not to do in tank design. Foreign engineers walked around the Maus, shook their heads, and photographed the curiosity from every angle. The machine inspired simultaneous admiration for the skill of the German designers and bewilderment at the absurdity of the very concept. By the early 1950s, the tank had definitively become a museum exhibit. The engine had long since gone silent and wouldn't start again. The rubber elements of the tracks had dried out. Inside it smelled of machine oil and rust. The Maus was moved to its permanent place at the Kubinka Tank Museum, where it took a place of honor among other captured German machines. Alongside Tigers, Panthers, Ferdinands, all the armor that had once seemed invincible but lost the war. Museum visitors always lingered longest beside the Maus. The tank's size astonished the imagination even decades after the war. People approached tracks that were taller than a human being, touched armor as thick as a hand's breadth, tried to peer inside through the vision slits. Guides told the story of this monster's creation, explained why it had never seen combat, and used the Maus to demonstrate how technical power without strategic sense becomes a useless heap of metal. Engineers of subsequent generations studied the Maus as a textbook of design errors. The tank embodied many interesting technical solutions: the electric transmission system, the hull sealing for underwater crossing, the powerful armament, but all these achievements were lost against the backdrop of one fundamental miscalculation. The tank was too heavy for its time. The technology of the 1940s simply could not produce an engine of sufficient power at an acceptable size and fuel consumption. The German designers tried to cheat physics, but the laws of nature proved unyielding. The story of the Maus became a cautionary tale among tank designers worldwide. When the Americans developed their heavy tank, the M103, in the 1960s, and when Soviet engineers worked on the Object 279, both sides remembered the lesson of the German giant. Both projects remained on paper or as individual prototypes. Tank forces developed toward medium and main battle tanks weighing 40 to 50 tons, capable of combining protection, firepower, and above all, mobility. The sole surviving Maus still stands in the museum today, a reminder of how grandiose plans shatter against harsh reality. The heaviest tank in the history of humanity, a machine into which the enormous resources of a dying Third Reich were poured, a marvel of German engineering and simultaneously a symbol of strategic blindness, never fired a single shot in anger. Its gun remained silent, its tracks never crushed enemy trenches, its armor never deflected incoming shells in real battle. 200 tons of steel became only an impressive exhibit, proving one simple truth: in war, it is not the biggest weapon that wins, but the most effective one.